Radiation, heat transfer methods, and sustainable building performance. Welcome to Building Knowledge 101. In this video, we explore how radiation through electromagnetic waves plays a key role in heat transfer in sustainable building design. Final method of heat transfer is what we call radiation. Radiation is a transfer of heat to the cold in the form of electromagnetic waves between two surfaces. When two surfaces face each other, heat will move from the warmer surface to the colder. Two examples for solutions for radiation are low E coatings on glass and sunshades on the framing system. Sunshades are an effective method of blocking direct sunlight and reducing radiation, which is also known in the industry as solar heat gain. Large glass areas still allow large amounts of indirect light in. So by creating sunshades, we're going to block the direct light and still allow indirect light to come in under them, bringing natural light to the interior and increasing the view space. Here you can see examples of a typical sunshade system. And here are examples of the sunshades being used on projects. And again, what they're doing is allowing greater amounts of glazing on the building envelope and cutting down direct sunlight so that we don't have the negative effect of solar heat gain. So most manufacturers that are working with curtain wall systems, storefront systems, are going to have a range of sunshade options available to you. Here are examples of different louvers that an architect can select from for having projected outriggers and put louvers into it, shading the glass below it. Also, most manufacturers do allow for custom designs if an architect has a particular shape they're looking for. Here's an example of a custom project. Sunshades typically project outward from the face of the building. Sunshades shading the glass below them, but they can also run horizontally across the front of glass, casting shadows below them. Here you can see simulated terracotta louvers suspended off the verticals of a curtain wall system. By putting these horizontal louvers across the face of the curtain wall, with the sun being at a high angle, they're shading most of the glass, allowing very little indirect light coming through. And in the overall picture you see on the left, they match up and work greatly with the terracotta panels that are on the main function of the building. Here's an example of horizontal blades turning a 90-degree corner. Sunshade options have vastly expanded and improved since they were first introduced. So there's lots of ways to use sunshades in concave elevations. Again, here you can see turning a corner. And also note these have been painted a custom process that mimics wood grain finishes. So these are an effective way of blending a nice design with the building and also blocking direct sun from hitting the glass, cutting down on solar heat gain. Here you see an example of that overall look of the building. Very nice looking project. Sunshades need to be positioned to maximize their shading. On an eastern and western elevation, you might want to have sunshades that run vertically because the sun's going to be coming in from the side. On southern elevations, you might want to have the sunshades running horizontally, so they're blocking sunlight that is predominantly shining down from above. Notice on the illustration on the left there, the angle of the sunshades are adjustable. Once they're set, they're fixed at that position, but before they're installed, you adjust the angle to maximize the ability to block direct sun. So based on the latitude of the project, the sunshade angles are going to change to get the highest efficiency of blocking direct sunlight. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.